Viscosity is the property of a fluid which shows resistance towards flow. It is some sort of resistance within the fluid molecules. To understand that viscosity, observe this picture here. It is a wedge inclined surface. If we release two droplets at same time, that is, one is water, another is oil, any oil, at same time on the wedge, these two droplets roll along the surface and reaches the ground. As we know, water reaches the ground first. It is because of water having very less resistance towards flow. Oil reaches the ground next because oil having high resistance towards flow. That means oil have high viscosity, water have less viscosity. If you observe the second picture, in this picture we are releasing the same two droplets again here, but there is no contact surface while these two are falling to the ground. Then what is the difference in velocities? Here the water reaches the ground first. Here what happens? Water and oil reaches the ground at same time. It is because though there is viscosity, but there is no viscous effect if there is no contact. Viscosity exists within the fluid here as well as here, but viscous effect exists only when there is contact to the fluid body, that is any solid surface. To understand that more clearly inside, in molecular point of view, what happens inside when a fluid element is moving downwards, when a fluid element is rolling downwards. To understand this more clearly, observe this picture in the side view. In the side view, it exactly looks like this. This is two-dimensional view. Now this is water molecule rolling downwards. Here, consider three molecules only. For better understanding, consider only three molecules, A, B, C. A is directly contacted to the wedge. B and C are not contacted to wedge. When A is rolling down, as soon as there is contact between solid body and A, the velocity of A becomes 0. Why it becomes 0? There is one condition called as no slip condition. For that condition, any particle when contacted to any solid surface which is at rest, then the velocity of that particle becomes 0. That is called as no slip condition. Okay, for no slip condition, velocity of A is 0 now, but velocity of B and C are not 0. However, their velocity reduces to certain amount. It is because of the cohesive force between A and B. If there is no cohesive force between A and B, the B velocity and C velocity never reduces. It is because of the cohesive force, the molecule A, which is at rest, pulls the molecule, that is molecule B, towards its direction. Okay, because of this cohesive force. What is cohesive force? The force of attraction between similar kind of molecules. It's A, B, C, both, all the three are similar kind of molecules. There is some cohesive force between them. Because of that cohesive force, B pulled towards A, so its velocity reduces. And again, B pulls molecule C, thereby velocity of C also reduces a little bit. More cohesive force, more resistance. That means the intensity, if the cohesive force, if the intensity of the cohesive force is higher, that means the resistance also higher, viscosity is also higher. So viscosity is finally due to internal resistance. That internal resistance is nothing but cohesive forces between the molecule. Next one is viscosity versus temperature. As we know, in liquids, when temperature increases, viscosity decreases. In gases, temperature increases, viscosity increases. See, there is a lot of difference between these two. In liquids, when temperature increases, viscosity decreases. Why? It is very simple. If we take a beaker and consider some molecules, if we increase temperature, the kinetic energy of the molecules increases. Thereby, the molecules move more randomly. The intermolecular space, the intermolecular distance increases. As we know, when the temperature increases, the volume increases. So thereby, the distance between molecule to molecule also increases. And definitely the cohesive forces reduces. When the distance increases, the force of attraction also reduces. So finally, when the temperature increases, the molecules move far away from each other, the cohesive forces reduces, and thereby the viscosity also reduces. Why? Because viscosity is due to cohesive forces. This phenomenon in liquids we generally observe in winter season, especially in our homes. The coconut oil bottles, if you observe, the coconut oil, when the temperature falls in winter, it will not come out easily. It is due to low temperature. When the temperature falls, viscosity increases. So when the viscosity increases, the oil will not flow out of the bottle easily. So what we have to do at that time is simply put that bottle in hot water or put that bottle under sun, so that the temperature increases, viscosity decreases, and the oil flows out easily. That is one example. Whereas in gases it is different. When temperature increases, viscosity increases. It is because the mechanism of viscosity here is not due to cohesive forces. It is due to another mechanism, that is molecular momentum transfer. We will discuss that in later videos, what is molecular momentum transfer. But here what to remember, viscosity in liquids is due to cohesive forces majorly. Viscosity in gases is due to molecular momentum transfer majorly. There is cohesive forces also here. There is some effect of cohesive force also, but that is negligible. Next, viscosity versus pressure. In general, viscosity depends on temperature more severely, more rapidly. When the temperature changes, viscosity also changes very quickly. That responds to temperature very quickly. But it is not like in pressure. When the pressure changes, viscosity not changes easily. It is because viscosity responds to pressure only at very high magnitudes, that is nearly 100 bar, 200 bar. At that very high pressures only the viscosity responds to pressure. Generally in normal pressures there is no change of viscosity with pressure. There are two names here for viscosity: dynamic viscosity and kinematic viscosity. Dynamic viscosity is represented with mu, mu. Kinematic viscosity represented with nu. For dynamic viscosity, SI unit is Pascal second. We know Pascal is Newton per meter square, Newton second per meter square. If we substitute Newton as with kg meter per second square, as we know 1 Newton equals 1 kg meter per second square. Substitute here, then by cancelling all the terms, finally kg per meter second, that is equivalent to Pascal second. These are SI unit. Whereas CGS unit is, if we substitute kg equals to gram, meter equals to centimeter, then it becomes gram per centimeter second. This whole term is called as poise, P-O-I-S-E, poise, this whole term. Next one is kinematic viscosity. SI unit is meter square per second and CGS unit is centimeter square per second, also called as Stoke. One Stoke equals to 1 centimeter square per second. One more important thing is conversion here. 1 Pascal second to poise. 1 Pascal second equals to 10 poise. This is very important. And the relation between kinematic and dynamic viscosity is kinematic viscosity equals to dynamic viscosity by fluid density. Generally, the difference between kinematic viscosity and dynamic viscosity is that is important. Kinematic viscosity, we define this kinematic viscosity, or we measure this kinematic viscosity for fluids deforming under the influence of gravity alone. But dynamic viscosity is not like that. We can represent dynamic viscosity in anywhere, whether the fluid is deforming under gravity or deforming under any external force or external pressure, anything, we can represent dynamic viscosity. But kinematic viscosity, we represent this kinematic viscosity for those fluids which are deforming, which are moving under the influence of gravitational force. At that situation, we express kinematic viscosity. And generally, while measuring the viscosity in viscometers, first we will represent viscosity in kinematic form. Then we convert to dynamic viscosity. Thank you.